Good morning. Today we are going to talk about how to name ionic compounds when the metal does not have the same charge every time. So we call these variable oxidation state metals. Variable just means that they can change. And these are usually your transition elements. So let's talk about the three exceptions to this. So these are your D block metals, except for silver, which always has a +1 charge. That one is fixed. Zinc always has a +2 charge, which is fixed. Cadmium is also always +2. Okay, so those are the three D block metals that won't ever change. Okay, everything else in the D block can have different charges. So the way that you figure out what kind of charge it has is to figure out what the charge is of what it's paired with. So we're going to do some examples here. We're going to look at FeCl2 and Cu3PO4. So the first step is the same as the other type of nomenclature. When you're just naming ionic compounds, you're always going to name the first element, which is the metal. So Fe is iron. Fe is iron, and Cu is copper. So after you name the metals, the second step is very similar also to ionic naming. You're going to name the second element with IDE if it's only a single element. So you can see here, this is just one type of element. Even though there are two chlorides, it is still just Cl, which means that it has an IDE ending. Okay, so we would say iron chloride for that one. This one, you can see after the copper, we have two different types of elements. That means it's a polyatomic anion. So that means that PO4, you should know what that is. It is phosphate, and you would write down phosphate. That's how we deal with anions that are polyatomic, right? Now, this is where the step gets different. We have to add a step 3. Because the reader does not know what charge iron or copper are, you have to tell them. And the way we do that is to use Roman numerals. Okay, so if you are not familiar with Roman numerals, you probably won't need more than 10. So this is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you'll see when you get to 5 is V. 4 is IV because it is 1 before 5. 6 is VI because it is 1 after 5. Okay, same thing when you get to 9 and 10. 10 is X. 9 is 1 before X, which is why we write it like this. Okay, so these are your Roman numerals, 1 through 10. That is what you're going to put after your metal. Okay, now the way we can figure this out is we know that the charge on the specific polyatomic anion is going to be fixed, and your charges on your nonmetals are fixed. So when I look at this, I'm going to go back up here to my formulas. Okay, so I know that my chloride has a -1 charge because I can look on the periodic table and figure that out. However, since I have 2 of them, I'm going to multiply my subscript by my -1 to get -2. Then I know that my positive part, which is the Fe, has to be added to that -2 to equal 0 because ionic compounds are neutral. So that allows me to know that iron in this case is going to be +2 because that is what satisfies this and makes it 0. So because of that, that is what I'm going to write. I'm going to write iron, and then I'm going to put in parentheses, your Roman numerals always go in parentheses, A2, because that is my charge on iron, and then chloride. So that is how I would finish that first example. Now, when we look at the second example for copper, I'll erase this now so I have more room. When we look at the second example for copper, I know that PO4 is -3. Okay, this had a 3 there. I know that PO4 is -3. That whole thing, that whole polyatomic ion is -3. That means this whole copper side must be +3 to equal 0. However, since I have 3 of them, when you write your Roman numeral, it is only the charge on one copper. So if all of my coppers equal +3, but I have 3 of them because that's my subscript, I would divide. I would say +3 divided by 3 means that each one of these is 1. So I would insert here between copper and phosphate a Roman numeral in parentheses of 1, and that tells me that copper is +1. Okay, now let's do some practice with this. Okay. So here's some examples down here. I personally think it is a lot easier to go from the name to the formula in this case. So let's do a few of those first. So this first example we have is nickel to bromide. So immediately, remember, when I go from names to formulas, I have to pay attention to charges because that's how I'm going to figure out what my subscripts are. So this 2 right here tells me that my charge of nickel is +2. Now, to find my charge of bromide, I have to think about a couple things. I have to realize that since it ends in IDE and it's just talking about bromine, that I'm going to get my charge from the periodic table. I'm going to go find bromine on the periodic table, go up to the top of the group, and realize that it is a -1. Okay, so I'm going to write down my Ni and I'm going to write down my Br. To get my subscripts, I know that these have to add together to equal 0. So you have a couple ways you can do this. You can write out your ions and say, okay, I have nickel +2 and I have Br -1. How many of each of these do I need to equal 0? Well, I need another Br. So then that means I'm going to have a 2 here and I'm going to have a 1 here. The other way to do this is to cross your charges. So I know that the charge here is going to end up being the subscript of the first thing, and the charge here is going to be the subscript of the second thing, except I can't have negative subscripts. So my -1, I have to take the absolute value for. So I would have a 1 next to my nickel, and I will have a 2 next to my bromine over here, which is what I do, right? I don't write the 1 because 1 is understood. So those are 2 different ways you can approach this problem. Okay, now I'm going to erase a little bit, and we're going to do the next one. So for the next one, titanium. The Roman numeral tells me it is +4. Okay, remember your first element is always positive. So whatever this is, it's going to be a positive number for your first element or your metal. So titanium is +4. Phosphite, I know since it ends in ITE that it is polyatomic. And I know that phosphite is -3. So then when I go to write my formula, I'm going to write a Ti, and then I'm going to write my PO3, okay? And then I'm going to cross my charges. So I know that this is going to be a 3, and this one's going to be a 4. So I'm going to write my 3 here next to titanium. Before I write my 4 next to phosphite, I have to put it in parentheses. If I don't, it looks like I have 34 oxygens and 1 phosphorus, when in fact I have 4 phosphites. So make sure anytime you have a polyatomic ion, you put it in parentheses before you add a subscript. Okay, so that is titanium 4 phosphite. Okay, let's look at the next one. So our next one is manganese, and it tells me that it has a +7 charge. Okay, and then I know that oxide comes from oxygen. So that is a -2 because of the group it's in on the periodic table. So then when I go to write this, I'm going to write Mn, and then that 2 is going to be my subscript for manganese. And then I'm going to write my O for oxygen, and my 7 is going to be my subscript for oxide because I just crossed them. Okay, one more example. Tin here is +2. Okay, so that's Sn. Now, hydroxide is one of those weird polyatomic ions you have to remember that ends in IDE. There's only a few of them. There's carbide, disulfide, hydroxide, cyanide. I think that's it. So this is one of those that you just have to remember is OH, and it's a -1 charge. So that means my tin over here is going to have a subscript of 1. And my hydroxide is going to become 2. It's really important that you put that hydroxide in parentheses. Otherwise, it looks like you only have 2 hydrogens and not 2 hydrogens and 2 oxygens. Okay? Now, the reason that I've included this next one is because it's kind of tricky. This is also a polyatomic ion you have to memorize. This is mercury 1. It is very rare that we will keep subscripts like this that are the same, that are not 1, because usually we reduce them to the smallest whole number ratio. But mercury is weird. Mercury 1 always comes in pairs. So you have to have Hg2. And on your polyatomic ion sheet, it tells you that your Hg2 is a +2 charge. So that makes sense when you consider that your Cl is a -1, so you have to have 2 of those to be -2. So this is mercury with a 1 Roman numeral chloride. Okay, mercury 1 chloride. And I put it on the polyatomic ion sheet because it is weird, because that's one of the only cases where you're going to have subscripts like this that could be divided out, but you don't do that because mercury 1 is different. All right, now on this next one, I know I have lead. Okay, so what I tell kids to do to see if it has Roman numerals is find it on your periodic table. If it is not one of your fixed metals, okay, which is group 1, group 2, and then aluminum, zinc, cadmium, and silver. If it is not one of those, then it needs Roman numerals. So lead, even though it's in the P block, it needs Roman numerals because it is not one of those elements that is fixed. Okay, so I'm going to put parentheses for Roman numerals because I know I'm going to need them. Then I look at the rest of the formula and I see that there's more than one element here. There's sulfur and oxygen. That means that that SO4 is polyatomic. And I know, because I've studied all my polyatomics, that it is sulfate. And I also know that sulfate is -2. That means that SO4, that whole thing, is -2. Okay, so I've got one of them. If it helps you to put it in parentheses like this, make sure you do that, because you're not going to multiply that 4 by -2. That 4 is part of the -2. Okay, so you're going to multiply that -2 by 1, if anything. And then you've got lead over here. So to make it equal to 0, your lead has to be +2. And that is your Roman numeral in this case. Okay, we're going to do a couple more, and then you guys can work on these guys on your own. So we're going to do, this one is vanadium. It's my first element. It is definitely in the D block. I see that, so I need Roman numerals. And then I recognize that after vanadium, I have a polyatomic again. It's PO4, which I have learned is phosphate. And phosphate, I know that PO4, that whole thing is -3, and I have one of them. So that means that my vanadium has to be +3 in this case so that they will equal 0. Right? All right, one more here we're going to do together. This one is chromium. And I see that that is also squarely in the D block. So chromium, so I need Roman numerals there. And then I'm going to look and see what I have next. Now, this is kind of an obvious polyatomic because I have that subscript on the outside and this is in parentheses. That tells me it's polyatomic. And so I know that NO3 is nitrate. And I also know that that nitrate is -1. But since I have 2 of them, I'm going to multiply. So that is -2. So that means my chromium has to be +2, right? So nitrate is -1, but I have 2 of them. So when I multiply, that gives me -2. So when I add chromium to that, it has to be a +2, right? Now, I would divide by my subscript here to make sure that I get my charge on 1 chromium, but since there is already only 1, I don't have to divide. Okay, but if this was a 2, I would say +2 divided by 2, and it would be chromium 1. Okay, so make sure that you divide by your subscript here, if there is one. If there isn't, it's just that is what your charge. Okay, hopefully this helped.